Thank you. I really appreciate that warm welcome. I'm Ryan Ware. I am currently with Carrier. A lot of you may know I was at Intel for 25 years. Regardless, let's see, I've been programming for 33 years. I've been doing product security for 25. I used to implement security features in crypto and DRM stacks. I have been an offensive security researcher, been a security architect, worked in central product security organizations. I've been the security architect on 3 different Linux distributions, and the only reason I'm able to say 3 is because they all failed so quickly. I do lots of work in the open source world. It's not part of my day job anymore, but I still think the work that the OpenSSF is doing is very important. So I'm glad I had the opportunity to come here and talk today. So, I wanted to talk a little bit about some interesting challenges that I have in my new position. And, you know, I talk about Methuselah here, and you know, Methuselah is a figure from the Bible who lived a very, very, very long life, and I have some interesting problems that I have to deal with in my new day-to-day. So you can see here in this image, somebody's building this big, huge, high-rise, and let me ask you: if you're building a big, huge high-rise, how are you going to feel if somebody tells you, yeah, hey, all that millions of dollars worth of equipment, that air conditioning equipment that you're installing, the big, huge, they're called chillers, the big air conditioning units that are on top of the building, thermostats, sensors, all this infrastructure you got to build into that building. How do you think they're going to feel if you say, yeah, we support that for 2 years? That's not a good market position to be in. So, we are in the interesting position that for some of these products, we have to support them for 25 years. I used to work in the in-vehicle infotainment system side of the world, and I was like, oh, 7 to 10 years, that's really long. Well, guess what, sweet summer child? This is a new world. And it's a very interesting problem. And with that said, that's the problem that I'm facing in my day job. I want to take my Carrier hat off for a few minutes and just talk from a personal perspective on some of this. So I want to go back for a minute. Back to the world of 2001, and I feel old. I've already met people here today that weren't even alive in 2001. So some of these cultural references, they're going to go like, what? But how long ago was this really? So 2001 is when Apple released their very first iPod. Okay, no smartphones, no iPhones, no nothing. This is the first iPod, and some of you who were really young back then are probably looking at this like, this looks like a Frankenstein piece of technology. And at the time, it was slick, it was awesome. I had one, I loved it. But you look at it now, I'm like, really? You built that? But very first iPod, movies that had just come out that year, Lord of the Rings, Fellowship of the Ring, one of my favorite movies, Harry Potter and the Sorcerer's Stone, Shrek, TV, sorry, these are more American references, but Friends and Sex and the City and The West Wing, and there was lots of good music that came out around then, but it's all really old now. I mean, again, from Lenny Kravitz, Hanging by a Moment from Lifehouse, Drops of Jupiter. These are all old things at this point in time, and the reason I bring it up is because I really want to talk a little bit about what we would be supporting now if we'd come out with a product that used Linux back in 2001. And this is insane when you go think about it. So going to 2001, state-of-the-art technology on Linux was Red Hat Linux 7.1, okay? By the way, I am old enough to actually have this box set at home on my shelf, okay? One of the big features of this Red Hat Linux was this was the very first Red Hat that had a Linux 2.4 kernel in it, 2.4.2. OpenSSL 0.9.6. That's an OpenSSL that's so old, Heartbleed has not yet been introduced into the code base yet. Okay? glibc 2.2.2, wget 1.6, Netscape Communicator, of all the weird things. Netscape Communicator, for those that don't know back at the time, used to be the only browser that really existed before Firefox and Chrome and all of that. PostgreSQL 7.0.3, Python 1.5.2, and for you Python programmers out there, yes, there were versions that old. They don't all start with 3 dot something anymore. And you know, for those of you that kind of recognize some of these version numbers, but kind of don't, you know, these are the modern version numbers for the latest releases of these stacks. So kernel is 6.16 for Linus's latest. OpenSSL is at 3.5.1 now. glibc is 2.42. So think of this for a second. 2.2 to 2.42. That's at least 40 releases. And it's actually significantly more. It's like about 60, including some of the other minor dot revisions. wget is only at 1.25, so only, you know, 19 releases. Netscape Communicator is dead, has been for a long time, but we might still be stuck with it, who knows. PostgreSQL 17.5, Python, its latest is at 3.13.5. Now, one of the reasons why I bring all of this up, one of the things that I have to deal with on a continuous basis, whether it's for my day job or the other things I work on, is the vulnerabilities that come with all of these that we all get to learn about, that get publicly disclosed every year. And so how many vulnerabilities are we talking about here? For the Linux kernel alone, we're talking about 2,483 that would have had to have been dealt with. OpenSSL, not quite so bad, only 79. glibc 2.2.2, 92 CVEs. wget is at 17 CVEs. Netscape Communicator, again, dead. PostgreSQL, 44 CVEs, and Python, only 57. Even some of these where it's like, oh, just 17, it's still a lot to fix 17 vulnerabilities. And for an embedded product, go get new firmware out there for people. This is hard. And the interesting aspect for a lot of this too is these numbers underrepresent the true number of vulnerabilities in these software stacks. Because after a certain period of time, when new CVEs come in, they're like, oh, well, that software is unsupported, so we aren't going to bother to put that version number into this particular CVE. And so what you end up having to do for some of these really old stacks is for every CVE that comes in, you have to go look at the code, at the patch, to go see, is this patching something that's in my really, really old version of the kernel? And I can tell you from personal experience, it's a pain, a big pain. And so some of you might be thinking like, oh, well, why don't you just go ahead and update to newer versions? And that works to some degree, but it also doesn't work to some degree because you can't change your hardware. And think about this. Typical 2001 PC, Intel-based PC is an example. I've used to work at Intel, I like Intel. Pentium 3 or 4, a 1 gigahertz to 2 gigahertz single core processor. Memory, 128 megs to 256 megs. Storage, 20 gigabytes to 40 gigabytes. Okay, this is very difficult to make modern day software run on these old systems. Go try to take your latest Ubuntu and go get on eBay and go get a 2001 class PC and see how long it takes you to figure out how to go install that. And not only that, like there's a perfect real world example here. So I've done work on Tiana Core, UEFI boot system, open source, and they're still using OpenSSL 1.1.1 because much of the existing firmware that they have to go replace doesn't have enough room for OpenSSL 3.0, because OpenSSL 3.0 is about 3 times the size of 1.1.1. Fortunately, they're able to keep 1.1.1 up to date with security fixes and things like that, but that's kind of a pain because it's out of date. It's unsupported upstream. And so all these vulnerabilities, unfortunately, are just getting worse. So this is the number of CVEs reported per year to the National Vulnerability Database, NIST, back in the US. So, hey, back in 2015, it was like 6,000. Yay. We used to think that was a lot. Last year, over 40,000 publicly, or 40,000 security vulnerabilities were publicly made available to everybody. And it's really hard to go to a customer and tell them, hey, yeah, don't worry about that vulnerability. I know it's public out there and there's an exploit in that we don't think we're vulnerable. And guess what? You're going to have to go fix it. You're going to have to go keep things up to date and keep things patched. And you see in 2025 here, it's only, was it 28,000, somewhere in there. But, if you extrapolate out the rate that these have been found for this year, we're talking about 47,000 for this year. So that's a 17% increase. It's not as big as the increase was between 2023 and 2024, but it's still a lot, okay? Now, like it says down here at the bottom, it's almost 130 new CVEs a day on average. Now, I'm going to switch modes here for a second. We'll come back to the CVEs here in a second. But I want to talk about why this matters. And that's because we won, people. Open source is everywhere. I remember back early in my career where companies were like, no, we can't use open source. No, we can't, the licensing, GPO, oh my goodness, no. And it's everywhere now. So at latest, so this is from a Synopsys report in 2024. But 96% of commercial code bases out there have open source code in them. I wonder what that 4% is that doesn't, but 96% does. And of that 96%, 77% by size of those code bases are open source libraries and components that come from other things. I mean, that's pretty awesome. I remember the days when it was like 0. As the Linux Foundation estimates, between 70 and 90% of software out there is open source. And it's hard to count, and I'm glad Synopsys got some behind-the-scenes look from some companies inside under NDA to be able to get some statistics out there. But there's a lot of it out there. Now, for better or worse, a lot of the CVEs that come out are related to open source software stacks. Not because open source is less secure or anything like that. It's a lot easier to go look at. You can't go look at some commercial company's code and go look for vulnerabilities in their code. You can go fuzz test it and do penetration testing of their stuff, but it's a lot easier for security researchers just to go, hey, I'm going to go look at their code. I'm going to go run static code analysis on it and see what I can find. This is an industry problem that's happening. So what if that 17% growth continues? This is an extrapolation. This year it looks like it'll be over 47,000. Next year, if it continues the same, it'll be over 55,000. As we go through the next 10 years, this projection shows that 2035 will have over 226,000 vulnerabilities. I don't know how we deal with that as an industry. I really don't. Then again, I didn't know how we would deal with it after 2017 when it jumped up so much. But there's just no sign of a slowdown here. I think the only slowdown might be if CISA stops getting funding and NIST is unable to keep on getting CVE reports, like kind of happened at the beginning of the year for a little while. Thank you. again, much of the volumes of these CVEs are due to open source projects because a lot of security researchers find them to be easy targets because they can go look through the source code and all that kind of stuff. That said, I think the OpenSSF is in a position to be able to help. And how many of you here actively participate in OpenSSF projects in one way or another? Just calling in to calls or working on projects? Good, good, good. Of course you do, Ron. So what is the mission of the OpenSSF? So the mission of the OpenSSF is to make it easier to sustainably secure the development, maintenance, release, and consumption of open source software that the world depends upon. And at this point in time, the world does depend upon open source. And you know what? So I saw, 4 or 5 hands that popped up. I don't know how many of you are passionate about security and open source. I imagine at least a little bit since you showed up. I want to say that there's plenty of opportunities for you all to be able to come in and help and move the ball forward and help make open source more secure. So I don't know how much you know about the OpenSSF, but there's a whole bunch of different a whole bunch of different working groups. And these are the overarching groups that kind of manage all of the work that happens inside the OpenSSF. I mentioned the Security Tooling Working Group first because that happens to be the one I chair and have run for 4 years. We do all sorts of kind of cool things in there. We have lots of different projects. I'll talk a little bit about them here in a second. That said, if your passion is AI and machine learning, there's a working group for you to go call into and join and help improve the world. If you're more passionate about representation and empowerment and belonging, there's a working group for that, Ware. If you are a stickler on like, hey, this is what secure code looks like when you write it, best practices working group is for you. If you want to go work on cyber policy, because like for better or worse, there's lots of new regulations coming around like CRA that we all have to deal with as open source developers. And if you want to help influence some of that, the Global Cyber Policy Group is a great place for that. We have a DevRel group that I want to make sure to talk about because they do a lot of great outreach to developers out there. There's the Open Resources for Baselines, Interoperability, and Tooling, kind of a mouthful, but we all call it ORBIT for short. It's a great place where we're putting together all of these tools to show how things can be made secure more broadly. There's securing critical projects, securing software repositories, supply chain integrity, and vulnerability disclosures. These are all great places to start if you want to go do some work. And then there are so many different projects, okay? So there's All-Star, and All-Star is also tied in with OpenSSF Scorecard to go show, help people measure the security of their repositories in GitHub and GitLab. There's best practices, there's BOMB-CTL, which is in my organization focused on, a lot of the tools in my organization are focused on software bill of materials. There's criticality score, fuzz introspector, which is in my group as well. GitTough, Guac, Minder, OpenBow. I'm not going to go into all of these. I'm getting short on time. But whatever your interests are, where you find the most interesting things about security, the things that make you passionate about security, there's something related to that going on in OpenSSF. There's an opportunity for you to go to contribute. There's an opportunity for you publicly to be able to say, hey, look, I'm doing this work over here. And by the way, look at my Git commits. And by the way, all of these little cool logos were done by all of the individual groups. Not all of them have them, but they've done some really cool stuff. So even if you're just into art, they love contributions for art too. I am definitely not an art person. I can't even draw a straight line. So in summary, the trend for security vulnerabilities right now is problematic. And with my carrier hat on, I'm looking at it going like, how am I going to support stuff for this long? The current trend makes it difficult to support software for any length of time, whether it's 1 year or 25. The trend isn't going to change for the better without addressing the security of open source software in general. And OpenSSF has many ways people can come help participate in making open source better. If you're interested in doing that, on the main OpenSSF page, there's a link up at the top for how to participate, what to go do. It shows calendars for all of the working groups and all of the projects that are under it. So that said, does anybody have any questions that I can answer? Or is everybody going to be shy? Don't be shy. I don't bite.
Yeah. It's always the person at the back.
It is always the person at the back. Run, run, run.
Hi, Ran.
Hello, sir.
Yeah, my question is, why not use AI to identify the vulnerable CVs and fix them? Already there are projects are existing, or no?
So that's a really good question. And I wish there was an answer that was that simple for finding all the vulnerabilities. And maybe we'll get there at some point, which I would love. One of the problems that we have with doing that is, first of all, to be able to go train an AI to be able to go find all the security vulnerabilities, you need to go find perfect code that has no vulnerabilities in it at all whatsoever to go train. and unfortunately, we keep on, a lot of these code bases at any one time, we fixed all the ones we know about, but then we keep on finding more, right? And so it would be great if we can do that. Hopefully we get there someday, because I'd love to be able to say, here, let's throw this AI over here and go fix all the problems. But we unfortunately aren't there yet. Maybe we will be someday.
Try as much not having a talk about AI, but it'll sneak in. Right?
Yep.
Other questions?
Thanks. Does this 25 years lifetime of a software happen by accident, or is it planned? I believe it's mostly happening by accident.
So to be honest, I don't have a good answer for that. Actually, tomorrow, literally tomorrow, will be my 1 year anniversary at Carrier. So I'm still learning a lot on why we have some of these things. Thank you. I appreciate that. And why is it 25 instead of 20 or 15 or whatever? I don't know, but it's even at 15, it would still be a daunting task to go deal with. So I just know if I was buying, if I was building a skyscraper, I'd be unhappy if I was told, oh, you have 3 to 5 years of support. Anything else?
I'm sure there's like a lot of people with tons of questions.
Yeah, and please, feel free to come, come tug on my sleeve while we're out there in the hallway, because I'm more than happy to talk to you all. Happy to talk about OpenSSF, why I care, why I do this work, and how you can go be better involved. So,
one last question.
Yeah, go for it.
So, managing the vulnerability management is one of the daunting tasks in many of the enterprise customers, because they have to keep updating the software. It's not easy when your application is running. You have to take a downtime and all. But today, I think the vulnerability management is a kind of like very rudiment in the sense like, hey, this package is a vulnerability. It just has to update it. They don't mind whether they're using it or not, right? Is it going to change the trend because of the number of vulnerabilities that are going up? So it's not really like NIST or anybody mandates that, hey, you need to have the upgraded version. Instead of that, hey, these are the components you use inside. You just need to update either, or if you're not using anything, go ahead and continue with that.
So that's a great question. I think for a while we're going to be in the mindset of like, hey, what are all the components that are in your thing, and then here, if you're hit with this, then you have to go update. And I think that's really what the software bill of materials efforts are all about, so people actually understand what's in their software. That said, I would actually love to get into a world where people don't have to take large updates all the time because we're replacing entire portions of the software stack, like entire components at one time. I'd love to get into a mindset where, like, oh, well, we only have to change this one little sliver to go fix this vulnerability and not the entire package. Because I know my wife complains every time I ask her to update her iPhone because it's going to take her like a half hour to get it done. And I'd love to get into a place where all of this is more transparent than anything. So, thank you.
Thanks so much, Ryan.